Chapter 5.1, using fundamental identities. So let's talk about some identities that we already know. All right, sine is reciprocals with who? Cosecant. So if you flip cosecant, it's sine. If you flip cosecant, it's sine. So if you flip sine, it's cosecant and so forth, right? Cosine goes with who? Who's its reciprocal? Secant. Tangent's reciprocal is cotangent. Quotient. So tangent is the same thing as sine over cosine. All right, and cotangent is the same thing as cosine over sine. All right. Now we're going to spend a lot of time on these Pythag identities. All right. So I'd like you to write out at least sine squared plus cosine squared is equal to 1. And then we're going to derive the other two. I honestly don't actually memorize these two. I only memorize this one, and then I derive the others. All right, so at least write down sine squared plus cosine squared equals 1. Sine of pi over 2 minus u is also cosine u. So every now and then you need to know its cofunction. Now, in cofunction world, sine goes with cosine. So if you have pi over 2 minus u, that's sine, if you have the cosine of it. All right, so these are your cofunction identities. All right. All right, now we're going to talk about even and odds. Now, what does even mean? Does anybody remember? This is in chapter 1, section 5. What does even mean? What does an even function mean? It's symmetric about the what? The y-axis. Symmetric about the y. All right, and odd means it's symmetric about the origin. All right, so that's kind of what we're talking about here. This is the way to remember it. This is the easy way to remember it. If it ever has a sign, in it, if we have sine of negative u, the negative gets to come out. All right? Does cosecant have a sign in it? Yes, it's the reciprocal, right? So it's negative, so the negative gets to come out. All right? Tangent, does tangent have a negative in it? Or does tangent have a sign in it? Yes, so the negative gets to come out. Does cotangent have a sign in it? Yes, so the negative gets to come out. All right, so those are all odd functions. All right, cosines are even functions. So if it just has cosine, if it doesn't have a sign, all right, if it doesn't have a sign, the negative goes away. All right, and that's the easiest to derive the other two trig identities. I honestly only have room for so much stuff in my little noggin. And so I only have sine squared plus cosine squared is equal to 1. And so I never memorized the other two, even though there are other two. The way that we do it is you divide everything by sine squared and you divide everything by cosine squared. So the first one, I'm going to divide everything by sine squared. All right. So sine squared u over sine squared u is 1. And then cosine squared u over sine squared u is what? Cosine over sine. Not tangent, but cotangent. So this is 1 plus cotangent squared u is equal to, now 1 over sine squared is actually just what? Cosecant squared. So now I have cosecant squared u. All right. So that's one of those 3 trig identities. All right, or Pythag identities, I guess you could call them. So this one, I'm going to divide everything by cosine squared. So if we divide everything by cosine squared, we're going to get the other one. So what's sine squared over cosine squared? Tangent squared, exactly. And then cosine squared over cosine squared is 1, is equal to 1 over cosine squared, which is secant squared. All right. And so now I have these other 2 trig identities. You see how I derived them instead of just memorized them? All right, I honestly don't memorize them at all. All right. Good. All right. Now, when is secant negative? What 2 quadrants will allow me to have secant to be negative? The what? 2 and, not 2 and 4, but 2 and 3. All right, secant goes with cosine. All right, now it also is saying, this is my constraint. All All right, just like chapter 4. Now I have my constraint. So when is tangent this time greater than 0? So what two quadrants tell me tangent's greater than 0? 1 and 3. So where must I draw this little triangle? In quadrant 3. All right. So now, what's secant? Ha ha ha. All right, so my hypotenuse is 3. My adjacent is 2, but it's really negative. Why is it negative? It's going left. All right, now I need to solve for my other side. So what do I use? I use Pythag. So what is it? 3 squared is 9. 2 squared is 4. We subtract and we get 5. So I have square root 5. Is it square root 5? No, it's negative. Why is it negative? Because it went down. All right. Now, once we have that little triangle, just like chapter 4, it's pretty easy. So what's my sign? All right. And then what's my cosine? Negative 2 over 3. And then what's my... Negative square root 5 over negative 2. However, what happens? My negatives cancel, so now we're positive. All right. And then, who's sine's buddy? Cosecant. What's cosecant? All right, so we got 3 square root 5 over 5. However, what does that actually... It's not 3 square root 5 over 5. It's actually what? It's negative. All right. And then, who's cosine's buddy? Secant. All right. So what's secant? Negative 3 over 2. And then tangent's buddy is cotangent. So then what's this one? 2 square root 5 over 5. So now I'm going to simplify sine, cosine squared minus sine. All right. So now I'm going to simplify these. You guys did these in Algebra 2. And we're going to do them again in pre-calc. All right, you guys did a little bit of these in Algebra 2. Now we're going to do it again in pre-calc. So what could we do to this sine x cosine squared x minus sine x? I can't combine any like terms. There are no like terms. But I could do something. It's an F word. I could factor. What could I factor? I could factor out a sine x. Let's factor out a sine x. What would I be left with? Cosine squared x minus 1. Wow, this is really lagging. All right. Now, is cosine squared x minus 1 anything? It is something. All right. Now we're going to have to manipulate these Pythag identities. How could I get to cosine squared minus 1? What would I have to do to this formula? Switch the 1 and the sine squared. So cosine squared minus 1 is actually what? Negative sine squared. So this is replaced by negative sine squared x. All right. And now I have sine x times negative sine squared x, which is negative sine cubed x. All right. And now we are done. All right. So we're going to be using those identities. All right, this next one. I have secant squared theta minus 1. I have secant squared theta minus 1. And again, I'm going to factor. I'm going to simplify this expression. All right. Well, what kind of form is secant squared theta minus 1 in? A difference of squares, right? So isn't this the same thing as like x squared minus 1? Except instead of x, now it's going to be secant of theta. Can you factor x squared minus 1? What does it factor to? X plus 1, x minus 1. But instead of x's, now what do we have? Secant. So now I have secant theta plus 1 and secant theta minus 1. And for right now, that's all we're going to do with it. All right. Soon we're going to solve it when it actually has an equation. But right now, we're done. All right. Let's look at this next one. I have 4 tangent squared plus tangent theta minus 3, and I'm going to factor it. So the way that I kind of want you to think about it right now is I kind of want you to think of it as like 4x squared plus x minus 3. All right, that's kind of how I want you to think about it right there. Well, can you factor that? 4x minus 3, and then x plus 1. All right. So instead of an x, now what is it? It's a tangent theta. So this actually factors to 4 tangent theta minus 3, and then I have tangent theta plus 1. All right. So don't be scared just because it has a trig function in it now. All right. What don't you like about this one? And I hope there's something that you don't like about this one. They're not the same. What do you mean by they're not the same?
Like, there's like
One's a cosecant and one's a what? Cotangent. Now, which one am I allowed to change? Which one can I manipulate? I can change the cosecant squared. All right. I can change the cosecant squared because what is cosecant squared? 1 plus cotangent squared. All right. Cosecant squared is equal to 1 plus cotangent squared. So all I'm going to do is I'm going to replace cosecant squared with 1 plus cotangent squared. So now I end up having 1 plus cotangent squared minus cotangent x, and then minus 3. What would I highly suggest you do right here? Combine like terms. So now I have a cotangent squared minus cotangent x, and then minus 2. All right. So the way that I kind of want you to think about it right now is like an x squared minus x minus 2. Can you factor that thing? I sure hope so. So what does that factor to? X minus 2 and x plus 1. So instead of x, now really what is it? It's a cotangent x. So now we have cotangent x minus 2 and cotangent x plus 1. All right, pretty good there? All right, let's do another one. So now I need to simplify sine t plus cotangent t cosine t. All right. Honestly, guys, t is not my favorite variable. T looks like a plus sign to me. However, it's used all the time. All right, so you're not getting away from it. All right. Well, can I factor anything out right now? Nope. Can I use any of these Pythag identities? Nope. Why not? Because they're not squared. I can't do anything. So what could I do though? Change the cotangent to what? Good. All right. When all else fails, convert everything back to sines and cosines. All right. That's the way I kind of think about it. All right. So I still am left with this sine t. And now cotangent t is actually the same thing as cosine t over sine t. And then it's still being multiplied by cosine t. All right. So I end up on my right side having cosine squared t over sine t. All right. And then I still have plus sine over here. Well, how do I add things together? What do I need? I need common denominators. Well, what's going to be the common denominator here? Sine. All right. So what do I need to do to this sine t? Multiply it by sine over sine. Because if I multiply it by the same thing over each other, that's really multiplying by 1. It's just manipulating the way it looks. All right. So really on my left side, I now have sine squared t over sine t. So now I end up having sine squared t plus cosine squared t over sine t. Do you notice anything yet? That's a Pythag identity now. So what is sine squared plus cosine squared? 1. So now I'm left with 1 over sine t. Well, what is 1 over sine t? Cosecant. Cosecant t. All right. And I think that one's beautiful. Because do you ever start with a cosecant t in there? No, but it's actually equivalent to just cosecant t. All right. Pretty nifty? All right, go. That's a peacock.